Okay, for our final calculus summer review video, we're going to look at logarithms, and this is at the very tail end of our review packet on page 14. There are three basic properties of logarithms that you want to go over. If you're adding two logs with the same base, you may combine them into one log, write that as log base b, and multiply the arguments together. Similarly, if you are subtracting two logarithms, again with the same base, then what you can do is combine those two logarithms into one and divide their arguments. The term that comes first, the one that is positive, will go in the numerator. What comes after the subtraction, that will be moved downwards. Finally, if we have log base b of x to the m, we can take that exponent that x is raised to and bring it down in front. And here they are, the three basic guidelines and properties of logarithms. Well, that being said, I'd like for us to do just a number of problems right now to help us out. Let's say that we'd like to expand some logarithms. Let's say, for example, 1, I am giving you the log base 5 of u squared times the fifth root of v. And I think it's very important to note that the properties that I've listed up above, not only can you move from the left side to the right side, you can also move from the right side to the left side. And in this case, because I see two terms multiplied together, this would be property number 1. What we can do is then write an addition of two logs, log base 5 of u squared plus the log base 5 of the fifth root of v. Now, a fifth root, I think it's very important for us to remember this just as well. A fifth root could be written as a 1/5 power. Hopefully you remember that. What we saw in earlier classes, like in pre-calculus, the nth root of a could always be written as a to the 1 over n power. Well, that being said, we can go one step further and use that third property and drop down these coefficients. We can say 2 times the log base 5 of u plus 1/5 log base 5 of v. And that would be expanding that expression and writing all powers as coefficients. Let's do another problem. Let's say, for example, 2, we might be given, say, the natural log of a to the 5th divided by b to the 3rd, and we're raising that all up to the 4th power. Natural log is a log of base e, and if we'd like to expand this, well, I think sometimes we get a little worried about what's happening. It doesn't quite seem to look exactly like property number 2 on this right-hand side here. It's looking somewhat close. It's just that we have this 4th power. Sometimes kids will ask if they could take the 4th power as it is and drop it out in front, use that third property. Indeed, you may. But remember, powers to powers are more powerful. We can multiply them together. So we could certainly multiply a 4 to the 5 and the 3 there and get a to the 20th all over b to the 12th. Then, using that second property, we could say, well, you know what? I do have this quotient. I'm going to write this, expanding this, as two logs that are being subtracted from each other. The natural log of a to the 20th minus the natural log of b to the 12th. Finally, we can take our powers and drop them down in front. And no doubt about it, we have gone as far as we can. I think it's very, very, very important to say that logarithms show up quite a bit in a calculus class. We're going to see them used repeatedly, so we have to be very, very comfortable with them. One last problem that we're going to take a look at would be condensing. In other words, for our last problem, could we take our logarithms, however many we have, and just write our expression with just one logarithm rather than multiple ones? So tell you what, we're going to reverse, I am so sorry, that third property, and say a coefficient out in front may be raised up as a power. And this will become log base 6 of x to the 1/4 minus log base 6 of y squared. And remember over here we said, hey, a to the 1 over n is the nth root of a. That would lead us to believe that we'd have log base 6 of the 4th root of x. So some real good review on fractional exponents, rational exponents, and radicals. And then finally, if you look at the top of the screen, we've got a subtraction of two logs with a common base. We may rewrite this as just one logarithm by dividing those two arguments. And that's as far as we'll go. And that's it for our calculus review. I hope it's going well for you. If you are having other issues, there are videos at Khan Academy and many other online resources. Wishing you the best. I know that all the calculus teachers are looking forward to working with you this semester. We're looking forward to a wonderful year. So see you soon.